Okay, hello children. Today we are going to do the second part of the chapter Light in Class 10. Now here what are we going to study? We are going to actually draw the ray diagrams. Okay, so let's do it. Ray diagram. For this, what I'm going to do is I'm going to show you there is a mirror and image is formed in the mirror. You can see a dog. The dog is the object and you can also see the image of the dog on the mirror in the same diagram. Okay, now we by using the ray diagram, what are we going to do? We are actually going to find out the distance of the image from the object, which is by the method which is called as the ray diagram. We are going to draw all the ray diagram on one fact that the light travels in a straight line and all the rays can be represented by drawing a straight line. Now, this method is locating the position, the size, and the nature of the image. Okay, so how are we going to do this? Now, let's see it. Now, before that, let us understand if I say that an image is formed on the mirror. So, erect image. I'm looking at the mirror and I'm getting the same erect image of myself. So this kind of the image is called as the erect image. Now sometimes what happens is we place the object in front of the mirror and the image size is much larger than the size of the object. Here you can see the object is small and the image is large. Okay, now this is magnified image. Sometimes what happens is if you keep the object in front of the mirror, the image which is formed is upside down. So this kind of the image is called as the inverted image. Okay, and next, sometimes what happens is the object is big in size and the image which is formed is of very small size. So we say such kind of the image is diminished image. Okay, so erect image which is straight, magnified which is larger than the size of the object, inverted, ulta, and diminished is the smaller size of the image. Okay, now let's talk about how to draw the ray diagram. To draw the basic diagram, take a scale, draw a line like this, then mark a point on this line and the line which you have drawn is the principal axis. Okay, now on this line you mark say a distance, say 3 centimeters for example. It can be more, it can be less. Then you mark a point on this line, call this a pole, and on this pole using a compass you can draw a arc. Now, if this is the point where it is the center of the circle is lying, and if you happen to draw an arc like this, then you get the part of a spherical mirror. Alternatively, what you can do is to draw an easy diagram. You have got a protractor with you now. This take the point P as the pole of the mirror. Take a protractor, draw the circle easy. Right, now remove the protractor. Now you get a concave mirror. Now you are drawing the basic diagram of the concave mirror. You have drawn the principal axis and you have also drawn the mirror and you have got the position of the pole. Okay, now in this concave mirror, you take a point in front of is 2 centimeters. It is the focus if we call it, and there is 2 centimeters more distance on it and it will be called as the center. But if you happen to draw it with a compass, the center of the arc which you have drawn, that is called as the center of curvature, and a point exactly in the middle between the pole and the center of curvature, you should take the focus, whatever is the distance. Okay, now you know how to draw the mirror, the principal axis, pole, focus, and the center of curvature. Okay, now once you have done that, you have to study about the rules for making the ray diagrams. Now, what are the basic rules? The rule number 1, if a ray of light which is parallel to the principal axis of a concave mirror, after reflection, it will pass through the focus. How? Let's say there is an object. The object is AB. There are infinite number of rays which is coming out of this object AB. But you are going to consider only one ray out of all these rays put together, only one rays which is coming out from the point A and it is traveling parallel to the principal axis, and after reflection it will pass through the focus. The yellow one is the incident ray and the blue one is the reflected ray. Okay, now this is the rule number 1. Now, talking about the rule number 2, if a light ray is passing through the center of curvature of a concave mirror, it is reflected back along the same path. Suppose if I have got an object here, out of those innumerable rays, I take one single ray which is in the path of AC. That means the ray should travel from the object and pass through the center of curvature. It go and hit the mirror out here. What will happen after reflection? It will follow the same path, but the direction will be opposite. Okay, so AC goes and hit the mirror here. After reflection, it is following the same path. जिस रास्ते गया उसी रास्ते वापस. This is the rule number 2. Now talking about the rule number 3. In the rule number 3, a ray of light is passing through the focus of the concave mirror. It becomes parallel to the principal axis after reflection. Let's take the object again. This is AB. There is one ray which is coming along the focus, hitting the mirror. After passing through the focus, after reflection, what happens? The reflected ray becomes parallel to the principal axis, and this is the rule number 3. Okay, now the rule number 4. What is rule number 4? You have got the same mirror, and now if a light ray is incident at the pole of the concave mirror, it is reflected back, making the same angle with the principal axis. Simple, bhai. Angle of incidence is equal to the angle of reflection. That means whatever the angle of incidence the ray makes with the principal axis, the same angle will be made by the reflected ray with the principal axis, the way it is shown in the figure. These are the basic 4 rules. To make any kind of the diagrams, you are going to use these 4 rules only, none other than that. Okay, so let's revise. Now 4 rules for making the ray diagram. Now the first diagram is shown in short in the first figure. The incident ray, if it is parallel to the principal axis, after reflection, it should pass through the focus. Okay, the second one, if the incident ray passes through the center of curvature, it should return along the same path and pass through the sea. जिस रास्ते जाएगा उस रास्ते वापस. Third rule is, if the ray is passing through the focus, after reflection, the reflected ray will become parallel to the principal axis, and if the ray is making an angle of I with the pole and principal axis at the point P, the reflected ray also will make an angle of the same size, which will be called as R with the principal axis. Okay, the angle made by the incident ray with the principal axis and angle made by the reflected ray with the principal axis will remain the same. These are the basic 4 rules. Right? Note down in your notebook, draw this diagram, practice it well. Okay, so whenever you sit to attend any of the lecture, you should have your notebook, pen, pencil and compass and all the things ready with you. Keep on noting. Now, I'm going to draw the diagram for each of the cases. Now, the first one is I'm going to keep the object beyond C. Now, there is a pole. 3 centimeters away from the pole, there is a concave mirror with a focus of 2 centimeters. Center of curvature, it is shown. So the radius of curvature is 4 centimeter. There is an object which is kept beyond C. The object is AB. And now I am going to draw the diagram by using the 4 rules which we have studied right now. The first ray which we are going to consider is the ray which is parallel to the principal axis, emerging out of the point A, going and hitting the mirror. As per rule, kahan se jayega? The reflected ray will pass through the focus. Okay. Now consider the other ray which is passing through the focus. What will happen to this ray after reflection? It will become parallel to the principal axis. Both of this ray will meet at a point, now as shown in the point, and the image of the object which is formed. See, I have got AB as the object and the image is inverted. And where is it formed? The object is placed beyond C, but the image is formed between C and F. What is the size of the image? You look at the size of the object and size of the image. First, it is inverted. Second, it is smaller. Third, the rays are actually meeting after reflection, so real. And it is inverted between C and F. If the object is beyond C, the image is formed between C and F, and the image is smaller than the size of the object. Okay. Now, writing about the property position. Position of the image is between C and F. Nature of the image, it is real, inverted, and the third is the size is small, that is diminished. Okay, so come on, pause the video and draw the diagram on your own in your notebook. Done. Only then you can move to the next slide. Okay, pause, do it fast. The next position, the object is placed at the center of curvature. Again, फटाफट draw करो concave mirror, pole, focus, center of curvature, and keep the object at the center of curvature itself. Right? What happens? Basic rules has to be followed. A ray which is parallel to the principal axis, after reflection it will pass through the focus. Okay. Now, if there is a ray which is coming from the focus, it is passing through the focus. After reflection, it becomes parallel to the principal axis. Where is it actually meeting? Just below the point B. So you can see that the image of the point A is made at, say, A dash, and B is made at the same position, that is B dash. So what you can see here, look at the size of the object and size of the image. They are of the same size. Where is it formed? C pe rakha object. It is formed at C itself. Right? Size is the same. Place is the same, but inverted. What about the size? It is of the same size. So let's write about the position of the image. Object at C, image is also at C. Nature of the image, are the rays actually meeting after reflection? देखिए, reflection के बाद दोनों rays meet कर रहे हैं, actually meet कर रहे हैं. So the nature of the image is real. Inverted. See, I had the object as AB. Image is A dash B dash. So that means it is ulta, inverted. And size, it is the same size. Okay. हाँ, फटाफट ड्रॉ करिए. अच्छे बच्चे लोग, गुड बॉयज एंड गुड गर्ल्स. चलो 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 ड्रॉ करो ड्रॉ करो ड्रॉ करो. हो गया? ओके. अरे रफ में ड्रॉ कर लो बेटा, कोई दिक्कत नहीं है. पता होना चाहिए नेचर ऑफ द इमेज कैसे फॉर्म हो रहा है. हाँ, स्केल यूज करना, कंपास यूज करना और फटाफट ड्रॉ करना. देखते हैं कितना समय लगता है. हो गया? एक्सीलेंट. Okay, now what happens when the object is between F and C? Closer. देखो पहले beyond C था, उसके बाद C पर लेके आए, अभी और पास लेके आते हैं. So again फटाफट ड्रॉ कीजिएगा. पोल, फोकस, सेंटर ऑफ कर्वेचर, प्रिंसिपल एक्सिस. ऑब्जेक्ट रख दिया F और C के बीच में. We have kept the object between F and C. Now basic rule has to be applied. If a ray is traveling parallel to the principal axis, after reflection it passes through the focus. And if it passes through the focus, it has to become parallel to the principal axis. Where are these two rays meeting? They are meeting beyond C. Now look at the image. The object is smaller, the image is larger. Where is it formed? Object is between C and F, the image is formed beyond C. Are they actually meeting? Yes, the image is real. Size is larger, so magnified. Okay, inverted. So what is the nature of the image? Where is it formed? Position beyond C. Nature of the image, real, inverted, and the third is magnified. Why magnified? The size of the image, you can see, is larger than the size of the object. Right? This is the condition when the object is between F and C. Done. The next one, when the object is placed at F itself. Again, फटाफट draw कीजिए. Concave mirror, pole, F, C, principal axis. Object is placed at F. Now, what happened? Basic rules. If the ray is traveling parallel to the principal axis, hits the mirror, reflects, passes through the focus. Now, if there is a ray, the light ray which is passing from here, you can see that if there is another ray which is coming from A, going in the same direction, hitting the mirror out here, after reflection, what happens? It gets reflected and Where is the position? I don't know bhai. These two rays are parallel to each other. हाँ, so जब पैरेलल टू ईच अदर होगा तो हमें थोड़ी पता है कहाँ पर इमेज फॉर्म कर रहा है. इट इज फॉर्म्ड एज इन्फिनिटी. और इन्फिनिटी किसको पता कहाँ है? व्हाट इज द नेचर ऑफ द इमेज? इट इज रियल, इन्वर्टेड एंड हाईली मैग्नीफाइड. पता नहीं भाई, हमने तो कभी देखा नहीं. कहते हैं कि रियल होगा, कहाँ जाके मीट करेगा? तो बोले इन्फिनिटी पर मीट करेगा तो भाई कहीं नीचे ही जाएगा. एक्चुअली मीट करेगा तो रियल. इन्वर्टेड तो होगा, हाईली मैग्नीफाइड, मतलब अच्छे से बड़ा से मैग्नीफाई होकर के रहेगा, लेकिन ये दिखता नहीं है. क्योंकि रेस पैरेलल जाते हैं और आप इन्फिनिटी पे जा नहीं सकते, है ना. सो दिस इज द नेचर ऑफ द इमेज. नाउ व्हाट अबाउट इफ इट इज प्लेस और पास में लेके आ जाते हैं. कहाँ पास में लेके आ जाते हैं? जब पास में लेके आते हैं तो पी और एफ के बीच में ले आते हैं. तो पी और एफ के बीच में तो हमने कहा कि भाई इसको फटाफट फिर से बनाइए मिरर. और अब यू हैव टू कीप द ऑब्जेक्ट बिटवीन पी एंड एफ. पास और सेम रूल्स. इफ the ray is there and basic rule apply करिए. if a ray travels parallel to the principal axis after reflection it has to pass through the focus. if there is another ray which is going from A hitting the mirror, I know it is passing through the center of curvature. जिस रास्ते जाएगा उसी रास्ते वापस आएगा. but you can see that these two rays are actually diverging away from each other, so they cannot meet. Diverging rays will not meet each other. So what will happen? Now these two rays has to be extended back to meet at a point beyond the mirror. They are not actually meeting. They appear to meet at the point A dash and the image which is formed is erect. सीधा खड़ा है image, invert नहीं हुआ है. The size of the image is larger than the size of the object. And then again what? It is formed beyond the mirror. So beyond the mirror, and they are not actually meeting. So the nature of image is virtual. So let's talk about the position of the image. It is behind the mirror. Nature of the image, it is virtual, erect, and also magnified. Magnified means the size of the image is larger than the size of the object. So this is the only position between P and F when the image formed is erect, inverted, erect and virtual. Erect and virtual. Is this clear? Right. बाकी सभी cases में आपने देखा the image formed is real. This is the only case where the image is virtual. You have to remember this. So come on, draw it in your notebook. हो गया? कीजिए, पॉज करके कीजिए. सुंदर डायग्राम बनाना है, जल्दी जल्दी बनाना है. बनाइए बच्चों. आपने ये इमेज कॉन्केव मिरर में रे डायग्राम कैसे बनाते हैं ये आपने सीख लिया. इसमें थोड़ी सी प्रैक्टिस लगती है, जरूर कीजिएगा. या थैंक यू सो मच.